These are the frequently asked questions for pre-calculus. This will be for section 7.1, day 1. And the first one that was asked for was number 30. Use the graph to estimate any solution of the system and confirm by substitution. I don't think I'm going to do the confirming by substitution. I think you guys can do that. But this one was just estimate the solutions. And what that meant was basically you were supposed to do this according to what you could see. So you wanted to look at what they used for intervals and figure out from the negative 9.4 to 9.4 that they had tick marks there of 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then just a little bit more. So that was going by ones. And the same thing for the y values, 1, 2, 3, 4, 5, 6. So they just put the 0.4 and the 0.2 basically on there to give you just a little bit of space. So they were saying what they want you to do is just take a look at it and say this intersection, and this intersection all appear to be solutions. So this one would be over, not quite 3, and up 1, 2, 3. So, you could say if it's not quite 3, maybe something like 2.8, and then it did appear to be up 3. And then because of the symmetry, you could do a negative 2.8, positive 3. And then this point down at the bottom appears to be at 0, negative 4. Now that is truly all they wanted you to do, was just use the graph to figure that out. But then you look at the answers in the back of the book and you think, oh, wait a minute, I have to find this exact. Well, we could. I went ahead and punched these in. But what you have to do with these is get them into a y equals format so that you're able to punch it into your calculator. So with x squared plus y squared equals 16, we would subtract an x squared from both sides. And then we would take the square root, which means we're going to have a positive and a negative square root of x squared plus 16. So it actually takes y sub 1 and y sub 2 to get that into the calculator, because you could have y sub 1 be a positive square root of negative x squared plus 16, and then y sub 2 equal negative square root of negative x squared plus 16. And then on the bottom here, that one we would just punch in as y equals x squared minus 4, subtracting 4 from both sides. So that is, in fact, what I did. And again, you'll notice that the first equation up there is the positive square root of negative x squared plus 16. The second one, negative square root of negative x squared plus 16. And then finally, our little x squared minus 4. And if I hit zoom 6, we should not be shocked to see that the top equation is for a circle that has a center at 0, 0 and a radius of 4. Now it looks a little distorted on our graphing calculator, and that's because our graphing calculator is showing like a wide screen view of what's going on. So now when we hit second trace, number 5, intersection, sometimes it's kind of hard to get Blinky to go right where you want Blinky to go, especially when there's more than one. Well, in this case we had 2 equations that we had to use for 1. So I've got the blue going there, and I'm going to hit enter. But do you see how Blinky went down to the red? I don't want it on the red. So I have to figure out, how do I get Blinky onto the black? And I actually had to hit the up arrow twice to get that onto my parabola and get that to work. And then you just hit through. And of course, there's the answer that we would have expected to see in the back of the book, negative 2.646 approximately, 3. And then we can go after the others. So second trace, number 5, I am back on the blue, which is the upper portion of the circle. And again, I mean, if you're using symmetry, we already know what this one is going to be. It's just going to be the positive of what we had for the others. But we could press enter, and then again up arrow twice to get it onto the black. Press enter and enter through guess. Again, no shock there. We had negative 2.646 as our ordered pair. This is positive 2.6463. Last but not least, we have one more that we need to see. And so I'm going to hop this down to the red and then do second trace, number 5. And, whoops, I'm going to have to hop back down again. Blinky went back there. So Blinky's on the red, and I press enter. And the good news is this time Blinky went to the black right away. Enter, enter through guess. And there we see that it's saying we have negative 8.226, but it's times 10 to the negative 7th power. So it is very close to 0. So we would write 0, negative 4 for that. Now that probably answered all of the questions that you asked for, but just in case, I'll go ahead and go through these. For 36, if you didn't get this one, it was probably because you still have your calculator set in degrees. We actually have to set this calculator into radian mode when we're going to graph cosine, which makes absolute sense. And then the bottom equation, we want y all by itself, so we could subtract 2x from both sides and divide by a negative 1. And it doesn't matter if you put in negative 1 plus 2x or 2x plus 1. It won't make any difference at all. Or I'm sorry, minus 1. There we go. Because what we're doing really when we're dividing by a negative 1 is just saying we want the opposite of everything that's there. So 2x minus 1. I'm going to stop the recording and get this one into the calculator. Are ready to go. And as you can see, I have 3 cosine of x in there. And 2x minus 1 equals y for the other. And again, what I have to do is go into mode and make sure that I put this in radians. When we want to look at cosine, we need that in radians. So now if I hit zoom 6, I should recognize our graph for cosine. And we know it's not a straight line. If you had this in degrees, you basically saw a straight line when you tried to punch y equals 3 cosine of x. And we see a pretty obvious intersection. So we hit second, trace, number 5. And let's get Blinky over here a little closer to the intersection so that Blinky doesn't have to do quite so much work. And like a good pet, Blinky tells us exactly what we want to know. So Blinky says at 1.134, comma, 1.268. That's our ordered pair that we need for that one. So this is about, getting it in there into units that are understandable and understanding, well, when we graph cosine, we have always used radians to graph that. And we have to do that. We have to use those radians. So the next one on your list was number 39. And for number 39, it is very similar to number 30 in that we have to go ahead and write this as y equals. So the top equation, x squared plus y squared equals 4. That is an equation for a circle with a radius of 2. And that will give us y squared equals negative x squared plus 4. So y equals plus or minus the square root of negative x squared plus 4. That means I'm going to have to type that in as y sub 1 and as y sub 2. And then x plus 2y equals 2. We're going to solve that for y. So 2y equals negative x plus 2. Y equals negative 1/2 x. And then plus 1. So 3 equations. Positive and negative for our circle. And then y equals negative 1/2 x plus 1. Again, I'm going to stop the recording until I get those punched in. These are all typed in, so now it's a matter of seeing the graph and finding those intersections. Here you can really see the distorted view that we get from the widescreen. It really looks like an ellipse instead of looking like a circle. And then what we need is to find the intersections. Now this one looks a lot like it would just be 2, 0. So the easiest thing for me to do with that would be to look at the table. And I'm going to get this back up starting at 0. And if you look at 2, you'll see that all 3 pieces of that graph have a 0. So 2, 0 is obviously one of the points that we have in that intersection. And I wouldn't have to use the intersect feature of the calculator to get that. We can just see, yes, it looks like 2, 0. I'm going to put that in and see what happens. Now, I might also say the same thing back here, except once I get the magnified view, I realize, well, that's not a perfect -1, 1 or anything like that. I'm definitely going to need Blinky for that one. So second trace, number 5, the intersection, and I do want the blue graph, the intersection with, and here we go again, I need the black. And so I have to make sure that I have Blinky on that black, not the blue again, but the black. And notice I had to hit the up arrow twice to get that to happen. And there it is, -1.2, 1.6. So this one had two intersections. One was at the ordered pair 2, 0, and the other is at the ordered pair -1.2, 1.6. And you had one more. Again, very, very similar. Actually, the bottom equation is all set up for us as y. But our x squared plus y squared equals 9 is a circle, center at 0, 0 with a radius of 3. So we would go ahead and subtract the x squared from both sides, and then take the square root, which again means plus or minus the square root of -x squared plus 9. We'll punch that in as y sub 1 and y sub 2. And then the bottom equation, like I said, it's already all set to go for us, so I'll stop the video while I punch that in. So now everything is in there. You can see I have a positive square root of -x squared plus 9 and a negative square root of -x squared plus 9. And there's our little 2 minus x squared. And this bottom equation that you see here, this is actually a parabola, and that's because we have this x squared term. And if we really wanted to, we could rewrite this as -x squared plus 2, so that we would realize this is going to be a parabola that opens down, but that its vertex will be at the point 0, 2. So now, if we hit graph, we're going to see our widened circle on that widescreen view, and then we should see our parabola. This is actually good news. We have two intersections, here and here. Now, when I take a look at it, it does not appear that they are perfect. It looks like we could go over 2 and a little bit maybe to get to this point, but it's not a perfect 2 down. It doesn't appear to be. Maybe it is a perfect 2 down, but what we're going to have to do is use the features of the calculator. So second trace and put Blinky to work. So here's the thing. I don't want to know what is intersecting with the blue graph. I don't need the top half of the circle. It is not intersecting anything. So I have to down arrow. And then I'm going to move Blinky over here closer to the intersection and hit enter. Now the good news is, since we were on the bottom, the graphing calculator knew to just go ahead and go with the black graph. And there it is, -2.048. and then -2.193. All right, one more time. We wouldn't have to. We should look at this and say, oh, this has symmetry. So we should get 2.048, -2.193. But if you miss that, you could always hit second trace, put Blinky back to work. Again, we need the down arrow to get Blinky to the red. And we'll move Blinky back over here closer to the intersection. Enter. Again, very nice that Blinky stays down below. Blinky knows enough not to try to use the blue up there anymore. And of course, there it is. So what we have to do if we're going to use our graphing calculator is make sure that we have everything solved for y. And once we do that, we can plug it in and we can use the intersect feature. But we do have to play around a little bit. There were some really tricky movements to get the cursor where we needed it to go.